Okay, so now that we have our shader done, it's time to finally make some magic. Make stuff actually appear on the screen. Da, 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 da. We've always wanted this. So what we're going to do is we're going to move down into the render function. Now, what we're going to first need, or what at least I recommend for whenever you're debugging, that way if something's not working, this will definitely tell you, hey, what is wrong? So create an H result. And an H result is basically what these functions were returning up here when we were checking for not SOK. So create that, that way you can see the values and whatnot. And then you can actually go to the MSDN and it'll tell you what some values are. And so it's like, oh, well, the problem of this was we didn't initialize this, or you're sending in wrong data, or you're using, I don't know, you're using null. So after that, whenever we render, what we're going to need is, we're going to, of course, need our device. We're going to need to access our graphics card. So m_p device. And we're going to call something called clear. Now, what clear is it's going to clear the back buffer. Essentially, basically think of this as the far background of what we're going to be seeing. All right? And usually you want to make this a color that you'd easily be able, well, at least whenever you're debugging, at least, you're going to want to make this a color that is easy to differentiate between. Like, if you're making a black triangle, or a silver triangle or whatever, you're not going to want to make the clear the same color, or else it's going to be tough trying to see it. So what we're going to do is we're going to first send in 0, 0, and then we're going to want to send in a couple flags. You're going to want to send in d3d clear _ target. And like I said, if you want to know what we're doing, MSDN is a great place. I will go into further detail as to what some of these flags are. However, if you want to specifically know for any of these things, just easily email me, send me a message, and I will clarify things. And we're going to do d3d clear _ z buffer. Next, what color do you want the back buffer to be? Well, since it's going to be a multi-rainbow triangle, I think we're just going to do d3d color _ xRGB, and we're going to do 0, 0, and 0. And if I'm correct, which I think I am, that should be black. And then once the float z, just put in 1.0f, and then for the stencil, 0. And that will be clearing. Now, I just built it. We're not actually using our H result. However, what does clear return? An H result. So HR. And I'm not going to put an if check because I'm way too lazy to put if checks for everything that we're going to be putting down. But usually if you put a breakpoint in here and you're checking what HR equals after each one of these is called, you'll be able to tell if there was an error or not. You'll be able to see SOK if it works. So next what we're going to be doing is we're going to be doing HR. HR, you call HR before everything except for normal logic, like we're going to be doing a for loop or making an unsigned int. There's no HRs for that. But next, what we're going to be doing is we're going to clear, or sorry, we just cleared. We're going to be beginning the scene. Might I add, you can call clear as many times as you want, but essentially whenever you create, or whenever you begin, before you begin to render and begin the scene and everything, you always want to clear, or else you could possibly maybe have garbage just on the screen. And essentially whenever you're wanting to do maybe multi, like screens, like if you have multiple cameras and you want to actually have those multiple cameras on the screen, like what they're seeing, you'd want to clear for every one of those screens. So that's just, once again, another future thing that we're going to be discussing. However, for this, just make sure you clear before. All right, so next we're going to be beginning the scene. And once again, I like to put curly braces because with the begin, there's always an end as far as DirectX goes. So the m_p device, and we're going to end the scene here. And then so, oh, that's ugly. There we go. So inside here, we're going to need to do some things. So we're going to first want to create an unsigned int. And it's going to be the num pass. And we're just going to call it num passes. Initialize it to 0. And what this is inside our shader, inside our technique, at least down here, I never discussed this, but we had our passes. And since we only have one pass, we're just going to be doing our vertex shader and our pixel shader. And that's that. That's all we're going to be doing. So for the number of passes, that would just be 1. We're going to need to grab that. So what we're going to do is we're going to take the shader that we're working with, hr equals m underscore p shader, and we're going to need to call begin on that because once again we're going to begin. Send in a pointer to our number of passes, so address of numpass. And then the next one, the flags, just send in 0. And once again put curly braces because begin and end. I like to do that just so that way you know that you need to begin and you need to end. So next what we're going to need to do is, once again, we're going to have another beginning. So hr equals m underscore p shader, and we're going to have begin pass. And it actually wants the pass. So what I like to do is inside here for unsigned int I equals 0. I is less than the number of passes that we have, and plus plus I. And we're going to want to do this actually for multiple times. Well, that's just in case if we had more passes, it'll do it. So send in I for the number or for the current pass that we're on. Now next what we're going to need to do is we're going to need to fill out any variables that we might need to manually set. Now back inside our shader, I had previously talked about the world view projection, which is up here. It's kind of by itself. It's like, what is this? That's basically called a uniform. I want to say that's what it's called. It's a uniform variable. And I think it's uniform, meaning that it's going to be used throughout it's going to be consistent throughout the entire call to that shader or loop through the shader. So we're going to need to set that manually CPU side before we actually go to render it. So hr equals m underscore p shader. And since it's a matrix, a 4x4 matrix, we can do set matrix. However, what we can also do is we can set value instead. And this will allow us to essentially set anything we need to do. However, with this, we just actually need to send in how big it is in bytes. So we'll just do that. So looking back at our shader, this is called world view projection. Copy that name, or world view projection. Remember, capitals matter. Capitals and spaces really do matter for this part. So what you're going to want to do is you want to send in that. Oh, Jesus. Well, actually, sorry, we're not going to do set value. We're just going to do set matrix, just because. But we're going to be doing this, and I actually need to copy it because for some reason it didn't copy over. Do that, world view proj, and then close it. And then comma. And now it wants basically a matrix, constant d through dx matrix pointer. So we're going to be sending in the address of, wait, we don't have a matrix though. So what do we need to do? It's time now for some matrix math. So essentially what the world view projection is it's the world matrix, the view matrix, and the projection matrix multiplied together. What the world matrix is it's where this object currently is in the world space. So let's say that we had our triangle and it's in, we originally make it in the center, but we want to translate it all the way out there, so it's all the way off in the distance. Our world matrix is where it actually is in our world. Our view matrix is our camera, essentially. Where is our camera at? Where is it looking? And so on. And our projection, well, like where can our camera actually see? Like what is how far can our camera see? How near can our camera see? What's the angle at which this can see as far as its field of view goes? Stuff like that we're going to need to set up. So it's time to actually go create that. So once again, we're going to go back into our app.h, and it's time to set up our matrices. So first off, we're going to need those 3 individual matrices. We're going to need the world, the view, and the projection. So d through dx matrix, and we're going to call these m underscore world, d through dx matrix, m underscore cam or view, however you feel like you want to call it, whatever you want to call it, d through dx matrix, m underscore proj. So for the world view projection. So now these really don't need to be initialized to anything. However, I do recommend you at least initialize them. This tutorial assumes that you know basic matrix multiplication, math, or whatnot. I will explain it once again in a future video. However, I just recommend you follow these quick and easy steps. So up here in the constructor, if you do D3DX matrix identity, that'll basically set the matrix to an identity matrix, which is essentially like the first, like, it's tough to explain. Identity matrix and identity matrix is like the starting matrix, how the matrix is going to be. So we're going to send in the address of our world, our view, and our projection. So do the world and that, and then I'm just going to copy this line, paste it 2 more times, m_view, and m_projection. And if you actually debug it, you'll see exactly what it does and how it works. So it's actually going to break right now if you try and build it, because we didn't actually fill out the stuff down there. But now we need to actually initialize our matrices to what they need to be. So what we're going to now do is we're going to just keep the object for our world in the center, but we're going to move our camera and we're going to set up our projection matrix. It is essential that you have your projection set up. However, you can actually have 0 and 0 for both of them. However, if you have both the camera and the world matrix at 0, or you never translate them, you will not see them. Or you will not see the triangle. I assure you that. Unless, of course, it's rotating towards you. But that's a perspective kind of thing. So we're going to do a D3DX matrix translation, and it wants a pointer to a matrix. So this is for the camera, because we're going to translate the camera forward. So that way it's looking, or backwards actually. So view. I like to think of the view as the camera. So, I mean, that's a very easy way of looking at it. So we want to actually move it backwards. So we don't want to move it over. We don't want to move it up. We want to move it backwards. So backwards by 2. Perfectly fine. So that's going to translate our matrix or our camera backwards. Next, what we're going to do is we're going to do D3DX matrix perspective FOVLH. All right, and this is for setting up our projection, m_proj, or the address at m_proj. So what it wants is it wants the field of view. So you can do this by doing D3DX to radian. And what do we want to convert to radian? We want to convert a degree. So convert 75 field of view into radians. Now we need an aspect ratio, which is essentially our width divided by our height. So we're just going to do 800.0f divided by 600 0.0f. All right, and that's going to give us our aspect ratio. Next, it wants our z near and our z far. Basically, how close and how far we want to see. Now, keep in mind, if the z near is if it's 0, you could possibly have graphical issues. Also, if you have a high near, you can possibly not see things that are actually really close to you. A number that I've come to love, 0.01f. And then make the fars 100.0f, I guess. These are usually what I use whenever I'm rendering with DirectX. So now build it, it'll still break. However, our matrices are ready. So now what we're going to do is, like I said, we're converting our 3 matrices into our world view projection. And basically what that is it is our world, so m_p, or sorry, not p, ignore p, world, multiplied by m_view, multiplied by our m_projection. And now we've set our matrix. So that's set our uniform variable inside our shader. Next, what we're going to need to do is we're going to need to set okay, so we're using the shader, but what data is it going to need? So we're going to need to set up our we're going to need to assign our 3 geometry variables. So we're going to do, we're not actually going to attach it to a shader, we're going to attach it to the GPU itself, and then the shader will check the GPU for that. So m_p device, and we're going to do set vertex declaration, and we're going to set it for the address of, wait, no, actually it doesn't want the address, sorry, m_b vertex declaration. And that's that for the vertex declaration. Next, for our, wait, one sec, it is actually, oh, my bad. Now compiling it, it should work. HR equals m_p device, set stream source. And what this is going to do is we're setting up our vertex declaration data, or not vertex declaration, our vertex buffer data. So stream number is something you really don't need to worry about. Just put it in 0. That's essentially for if you were doing instancing, but you're not, so you're good. And then next you need to send in the buffer, m_p vertex buffer. Offset in bytes. The thing I talked about in my one segment with the buffers is this is the offset in the buffer it's going to be looking at, and then it automatically knows how big it is based on the vertex declaration. But the offset is 0 because we're not moving over. And then stride is per vertex, how big is it? So you need to still send in the size of vertex declaration or vertex data. So sorry, I don't know what I was saying with the vertex declaration. The stride is how big each vertex is. Okay, so HR equals m_p device, and now this one's a little bit more obvious. Set indices. Oh. And this is to set our index buffer. So m_p index buffer. Now we currently have all of our stuff set for our shader. I mean, we've sent in the data that we need, we've set up our indices, we have our declaration. So what now? I guess it's time to call our shader. And we're going to commit our changes. And basically what that's going to do is it's going to finalize all this stuff. Remember, if you don't call commit changes, I will repeat this again. I can't tell you how many times I've actually had problems because I didn't call this. Call commit changes after you're done with each object, or not each object, but each pass. Just commit your changes. And then next, it's time to render. So the moment we've been waiting for, HR equals m_p device. And we want it to draw our index primitive because it is an indexed triangle or indexed object, indexed, yeah. So for the D3D type, or D3D primitive type, D3D PT underscore triangle list, and send in 0 for the base vertex index, min vertex index is 0, and then the number of vertices. How many vertices did we have? If you can remember, we had 3 vertices. Start index, 0. And this is just in case if there's an offset in your index buffer. And then your primitive count. How many primitives? How many triangles did we have? We had the front and the back, because we have our index buffer was the front and the back triangles. So 2 triangles. And compile. And now, once again, with our begin, we do have an end. So HR equals m_p shader end pass. And it's perfect. It is beautiful. We are all happy campers now. However, if you run it, it still won't show anything. Why? Well, now that we've actually drawn all this stuff to the screen, we want to actually render it to the screen. Okay, basically what we're doing is, when we first did this, we have the main window, and we're drawing to that main window, or render target. Render target is, the main window. And so basically what we need to do is we need to take all this stuff, and we need to throw it onto the screen now. So what we're going to do is we're going to do HR equals m_p device, and this is the final part you want to present. And assuming you're not doing anything special, just going to throw in zeros for every single one of these guys. And now next should be working. Just as a quick reminder, you want to call clear, or assuming you don't have to be doing anything special, you want to call clear, call begin scene, and then render all the objects you have. In basically, it would be in here. Every single object you want. Then after you're done rendering everything, you want to end the scene, and then you want to present. Okay, so essentially per object. So if we wanted to have like three triangles rendering, just copy and paste 3 times. It's gonna be they're all gonna be in the same spot, but that's still rendering different objects. So now we're about ready to run it. However, there is just one bug that we do need to fix that I did find inside. For this VS output, we actually need to change this to float 4. I accidentally made it a float. That is wrong. That is incorrect. We want it to be a float 4. So unfortunately, we're gonna need to hit F6 or whatever. You're gonna need to rebuild it all. We're going to need to actually open it up. Oh geez. Open project. Alright, so we're gonna grab that project URL or path URL. Why'd I call it a URL? Gosh, I can't click. Alright, so we're gonna copy over the color shader effects. And we're going to go to our desktop. And we're going to go over into the copy here and copy over that. Make sure you override it. All right, so now it is time to run it. Woo! We have our shader working with a triangle. It worked. All right, so now that we have our triangle rendering on the screen, like I said, like this is unmoved. We just moved the camera back. However, I think that we need to at least get it doing something, so that way, stuff actually is, doing stuff. So what we're going to do is we're going to actually create a float inside here. It's just going to be used for the rotation of our triangle. So we're just going to call this float rotation. And we're just going to throw it up top here and make sure you initialize it to 0. Now, there's a much better way of actually getting this thing to rotate. However, this is going to be a quick and easy way of getting it to work. So now we're just going to do rotation plus equals 0.05f. And then what we're going to do is we're going to do D3DX matrix rotation. And we want to rotate it along the y-axis. Now, once again, this is under the assumption that you know how matrices work. Once again, I will be making a video that explains more about matrices and how to get things to be awesome, super cool. But what we're going to do is we're going to send in the address of m_world matrix or world, and then once it's angle, just send in rotation. So what this is going to do is every single frame that we render, it's going to actually add our rotation by 0.05. And so it's going to add it, and it's going to be essentially rotating it in a circle or around. You'll see. Yeah. So there you go. And the speed, like I said, it's bad to actually be doing it this way as far as rotation goes by just adding it like this. Because if you have the VSync off, it could be changing in speeds all the time. You'd essentially want to use timers in order not to update it, but that's once again going to be explained in a later video. So there you have it. We have our rotating triangle of amazing rainbowness. It's great. It's awesome. And now you have the skills to do basic DirectX things. Hopefully you've taken something away from this tutorial. Hopefully you liked my video. If you do have any suggestions for a future video, if you have any questions about the current video, if there's any problems, email me, send me a message on YouTube, add a comment. I'll get back to you as soon as I can. Other than that, thank you for watching, and I hope you liked the video. Subscribe, favorite, like, thumbs up, everything. Do all those things, and I'll catch you later.